Hello, welcome back to the Introduction to Python course. In this chapter, we're going to be talking about Chapter 8, which is more about strings. Now, we've talked about strings in the past, but there's more to them than meets the eye. In particular, we're going to be talking about basic string operations, string slicing, testing, searching, and also testing, searching, and manipulating strings. All right, so basic string operations. So we've worked with a lot of different operations already that use strings. We've used them to hold text. We know that they can hold text. We can concatenate them. We can talk about all these different operations we have. But there's many different tools for actually examining and manipulating strings. So in the past chapter, in chapter 7, we've talked about lists. Well, strings operate in a very similar manner because strings are a type of sequence. So many of the tools that we use to work with sequences will work with strings as well. So for example, when we use the for loop on lists, we could do for item in list. Well, with a string, we can use for character in string, and that'll give us each individual character of a string. Now this is useful when we need to iterate over a whole string or look at individual characters of a string. We can also use indexing, like we've done before, where we do something along the lines of, say, if we wanted to, say, do string str equals my string, like that. Then we can do for index in range of length of str for our string. And we can then print str bracket index. So we can use indexing like this. We can also just use a standard for loop. So we can do for character or char, whatever you want to call it, in str print char. So if we run this, you'll see we have my string right here. So this is the first way right here. I'll put a couple print statements here just to start to split this up a little bit. Okay, I'll just do that to split it up. Okay, if I run this one more time, you'll see it says my string. So it gives each individual character down here. And then the other way also gives my string, just like that. So just like when we're working with lists, we can access individual elements of a string or the characters of a string because Python stores these lists in the same way as it does other sequences. It stores each individual character, and those characters comprise the iterable sequence, or the sequence in this case of string, which then it uses to print and store our text. All right, here's an example of that again. So here you can see there are blah, we're just counting the S's in this case. So we're saying, give us a letter. If we input the letter S, it's going to find the S right here on the end of the end of the word is, and then the S right here on sentence. And that's how we can go through and count the number of letters we want. And then that'll output there are 3 S's. Similarly here, if we do this, we can say which character is at that position. So if we input the word character input index, right, we're asking which one, which index we want. And in this case, we're saying the text is, this is a sentence I wrote. And we ask for the index of 2. Then we go T right here is 0, H is 1, and 2 is I. So that gives us character 2 is I. So we can check both the indexing, we can count letters. We have full access, like we talked about over here as well, to strings, which is very useful because when you're working in programming, there's a lot of different operations and a lot of different things that do need you to actually operate and examine and manipulate strings. However, keep this in mind, just like with the lists, if you're trying to access something that's not in the list or not in the sequence, not in the string, you'll get an index error. So if I try to go over here and we say my string, and that's 0, 1, 2, 3, 4, 5, 6, 7, 8, so that's 8 long. But if I try to do print str bracket 9, like that, and I run that, right here you'll see it crashes right there. So the rest of this runs through, but at the end of the program it says, hey, that's not actually out of range right there. Okay, so be careful with that. And just like with lists as well, we can also use the length function to actually find the length of strings as well. So we have the same operations we have for lists. We can use many of them, not all of them, but many of them on strings as well. Okay, just like we talked about before, and we've seen this already before, so we'll just go back to this pretty quickly. You can concatenate strings as well. because again, just like we would concatenate two lists, so if I come over here in our scratch pad here, if I do list LISA for list A, is we'll do 1, 2, 3, 4. Then I do LISB equals, and we'll do 5, 6, 7, 8, like that. I can concatenate these to LIS, which is LISA, yep, like that, plus LISB. If I do that and I print LIS, and we did this in the last chapter, but if I do this, you'll see we have our list concatenated. Just like that, we can also say A equals the string hello, B equals the string world, just like that. If I then say C equals A plus B, and I print C, you'll see that we have both of them concatenated. Now, notice here, unlike the list that will put the comma in between the two items, so here we put an extra comma between 4 and 5, when you concatenate strings, it does not put an extra space. It just puts them directly next to each other, which, if you think about the fact that the string is a sequence, makes sense because in this, a space is also considered a character. So if we were to add spaces, now we're adding new items to the list, and we don't want that, or the new items to the sequence, and we don't want that. So the way it works is it will put every character in that sequence in the correct order, and it will move, and it will put them together, just like with the lists. Okay. So just like with tuples, strings are immutable as well. So with that being said, once you create a string, you cannot change it. With that being said, if you see with a string, you cannot use string bracket index of a new character. So for example, I cannot come over here and say C bracket 0 equals A, like that. If I run that, it's going to give me an error because I can't do that. If I wanted to change the first letter of this string, we will have to use some string operations we're going to go look into later to just edit the different parts of the string. Okay? So just keep that in mind. Lists are mutable, tuples are immutable, and strings are also immutable. Okay? Now we can obviously, just like with tuples, we can get around the mutability part of it, and we can change tuples, and just like that, we can also change strings. But just like with tuples, we do not actually change the original tuple, we create a new one based off the old one. And just like that with strings, we're going to create new strings based off of the old strings. All right, so an example here again, you have Carmen. You cannot say name plus, you can add it together just like that, but then you cannot change it as well. So for instance, if I come back here real quick, when I add another part to the string, it's creating a brand new string, just like we talked about before. The old string is discarded, and the brand new tuple or brand new string or brand new sequence, the same immutable sequence of string, is being put there instead. All right, so let's see if you guys understand this. So if I were to ask the question, what is the index of the first character in a string? The index of that string starts at 0, just like it does with a list. Then if I ask if a string has 10 characters, what is the index of the last character? Just like with lists, it starts at 0, so the last character has an index of 9. If I ask what happens if you try to use an invalid index to access a character, you should respond with, or you should understand that you get an index error exception. After that, if I ask you, how do you find the length of a string? Simply, just like we did with the list, we do len, the length function, but instead of putting a list in there, we put the string. Now, if I look at this right here and I gave you this code and I say, what is wrong with this? We have animal equals tiger, and I'm trying to change the word to liger, okay? So you're going to try to change bracket 0 to an L. Well, the problem here is that strings are immutable, and as such, you cannot change this. So if you wanted to do this, you would have to use some other string operations to remove the T and put the L there instead. Specifically, those operations are not changing the original tiger string there. Instead, they're making a new string that starts with L and has all the other parts of tiger. We'll talk about that later on. All right, so let's go ahead and try this. If I wanted to write a program that asks the user to enter a series of single-digit numbers with nothing separating them, so just like right here where it says 2514, then the program should then display the sum of all the digits, all the sum of the digit numbers in the string. So what that basically means is you're going to take 2514 and you're going to say 2 plus 5 plus 1 plus 4, which means it should return 12. So let's go ahead and try that. So what we're going to do is we're going to come over here to 8-2 because that's the problem that we're working on. And I highly recommend you guys have different Python files for each of the examples. And the first thing we're going to do is we're going to get the user string of numbers. Okay? We're going to do numbers. Oops, make sure you tabbed in. Numbers equals input, or say enter a series of single digit numbers with nothing separating them, like that. Then what we're going to do is we're going to iterate through the string of numbers and add them up. Okay? So because they're a string of numbers, we cannot just use the sum function right now, so we're going to have to iterate through them. So we'll say sum equals 0. That. So that's our sum. And we'll say for value. Remember, there's two ways of doing this, and we'll go over both. In numbers. So that's going to give us each of those. We can then do this. Now remember, we need input validation. Now we could input validate up here, right? Or what we can do instead is we can do try, and we can say sum plus equals int of value. And what that's going to do is it's going to try to cast value to an int, and if it can, it will add that to sum. If there is an issue, we'll just pass. You can print something here if you'd like. You can print something like invalid character found, but we can continue with what we have, and we'll just pass from there. All right, so that's the first way we can do it. I'll show you here in a second here this other way, but let's go ahead and finish this up first. We can do print out the sum as well. I'm going to do print, we'll say your total is some value here. Now, when we do that, we'll use the dot format option there, and we'll do sum, just like that. So now it'll say your total is, and whatever we get. So if I run this now, let's go ahead and add some numbers. We'll do 1, 2, 3, 4, and it'll say your total is 10. Because if we do 4 plus 3 plus 2 plus 1, it's 4 plus 3 is 7, plus 2 is 9, plus 1, that's 10. So that gives us a total of all the numbers we put in. Now, if we run this again and we do 1, 2, A, 3, 4, it'll tell us we have an invalid character, but it will still give us the total of 10 for all the numbers we actually added. If we go through and we put an AAA, it'll say invalid characters all across the board, and because it could not cast any of them to an int, the total is still 0. All right, so that's the first way of doing it. Remember, the other way you could do it is you could also do, and you have the option, so you can change this part right here, or this part right here, and instead what we can do is we comment that out. We can also do index equals 0, or we can do for index in range of length of numbers. We can do that as well. We could do that. The only difference is now our value will become numbers bracket index. Okay, if we run that, you'll see this is working. We'll do actual numbers this time, so it's not going to fail. And you'll see it's still working fine. So you can take your pick. Remember, you have your 3 different approaches to loops. You have your for value numbers. You have your for loop that controls the index. And remember, you also have your while loop that also controls the index. So with the loops, remember, you have multiple options. We'll just leave it as a simple one for this case because it's all it needs. We'll change this back to value. And we're good on this example. All right, so going over this one last time, we're going to get a string of numbers from the user. We're going to iterate through the string of numbers. Each one of them, we start with our sum, that's our accumulator. And for each value in that, so each character in our string, we're going to cast it to an int. If that process works, we're going to add it to our sum. And then if it does not work, we're going to print that we found an invalid character, and we will continue because we want to add any numbers that do exist in the string. Then at the end, we'll print your total is whatever it is. Okay? All right. So what I want you guys to do is pause the video, and I want you guys to try this example. So Morse code is an actual code where each letter of the English alphabet and each digit and various punctuation characters are represented by a series of dots and dashes. The following table shows conversions. What I want you guys to do is write a program that asks the user to enter a string and then converts that to Morse code. So what I want you guys to do is I want you to try this on your own. I will give you this first starting point. So what I would like you guys to do is start by building this table here. This is, as we talked about before, this is a two-dimensional list. So you'll see here we have our space. This all corresponds with this table right here. Okay. We have our space, which leads to a space. 0 is 5 dashes. Go through, copy this down, and what we're going to do is after you unpause the video, we'll go through actually how to solve this problem. So go ahead, put the table in, try it on your own, see if you can access this two-dimensional list here and use that as a conversion table to Morse code. And then once you're ready, go ahead and unpause the video and we'll go over it together. All right, did you give it a shot? All right, so let's see how we're actually going to go about doing this. So the first thing we see is that we need to make a program that will convert our text to Morse code. Now we have all of this nice table up here that will give us an actual information. Again, this is just a two-dimensional list right here. Each inner list is the conversion. And what we're going to do is we need first a function that's going to give us our text that we give it to Morse code. Okay, that'll be our text there. It's going to get input some text that we're going to give it. And this is going to be text to Morse. And I like to do this when we have larger programs. And we're going to convert the input text to Morse code with spaces separating each of the characters for translating purposes. Now the spaces in between them will make more sense here in a second. So what this is going to do, the first thing we're going to want this to do is we have our text. So once we've translated it, we need some way to store it. So we're going to set up our output string. This will be our output. This is what we actually hold our Morse code. And we're going to keep this as empty. Okay. After that, we're going to then iterate through each of the characters of the text. So we'll say for each character in the input text, we're going to get the Morse code sequence. So how are we going to do that? We're going to do for character in text. That's the first one. We talked about that over here in Scratch. You can do, like we said before, if we have hello like that, we can do for character in A. We print character. We run that. It'll give us hello because it's going through just this string. So back over here, we're going to say for character in text. So whatever you give us, we're going to go through each character. Then for each character, we want to find the actual Morse code sequence. So we're going to do for item in our Morse code list. So we're going to go through this entire list here. And what we're going to do is we're going to check. We're going to say once a character is found, concatenate its Morse code sequence to output. So how are we going to do that? We're going to say if character. Now notice here we have them all as uppercase. So A, B, Y, R, whatever are all uppercase. We'll do dot upper equals item. Now notice here we're going through. So remember, when we're looking at two-dimensional lists, this first one dereferences it the first time. So now when we do for item in Morse code, we're getting each of these lists one at a time. So we're going to get this, then we're going to get this one by itself, and this one, and so on. So what we're checking is we're saying for if the character we put in from our text is equal to item sub 0, the first one. That's going to be right here. That's going to be this first item. So I, M, Q, U, Y, R, 4, 0, spaces, etc. If it's equal to that, so it's equivalent to that, then we're going to do output plus equals, so our output string right now is empty, plus equals our item of 1. So our item of 1 is the actual, remember we're looking at each individual list, so item 0 is just the actual character that we're looking for, and item 1 is the Morse code sequence. So we're going to plus equal item 1. Now remember, if we want to ever translate this back, we want to put some other kind of delineator there to know when certain characters end. So we'll also add a space after each set of each Morse code sequence to help us understand when one Morse code sequence ends and which one starts. And that's it. That's all we have to do. So after that, we're going to go ahead and just return our output, just like that. And we can go ahead and test it. So if we come into main here, we can go down here and say message equals input. We can say enter a message. So at this point, we're getting user text input. So remember to comment your code. And then we're going to convert the text input to Morse code. So what we're going to do is we're going to say the Morse equals text to Morse of our message, just like that. That'll pass our message to our actual function that we just built. And if we print Morse afterwards, we'll see the result. So let's go ahead and give this one a try. So if we say hello world and we hit enter, we now have this. So you can see each one of these has our spaces between them, just like that. So it's each of our letters. And then we have a larger space, 3 spaces to be exact, for the actual between 2 words. Okay? So if you look right here, we have 4 dots. If we look at the actual table, we find H right here, and that's 4 dots. Then we have our E right here, which is 1 dot. Then we have LL, which is dot, dash, dot, dot. So that's LL. And then O, which is 3 dashes. So that's our hello world right there. So that's our hello. This part right here, up to here is hello. And this part right here is world. Okay? Now, if we want to go a step further, what if we wanted to convert back? So it's a little bit more tricky, but what we can do is we can do another function called Morse to text. We'll bring in our Morse code that we just made. And again, when you're building with bigger functions and bigger pieces of code, using some kind of little descriptor comment above each function helps understand which each of the functions are doing. So here we'll say Morse to text, and then we'll say converts input Morse code with spaces between each of the Morse code sequences to text. That's all it's doing. What we're going to do in here is we're going to do the exact same thing. We're going to set the output string. So our output in this case will be actual text by itself, but will be empty still. Then we're going to set a couple temporary current strings. So when we're looking at this, we need to process this initial sequence, so like these first 4 dots. So we need to grab them first. So what we're going to do is we're going to say current equals an empty string and index equals 0. So then we're going to iterate through the Morse code sequences and translate. Okay? So we're going to say while our index is less than the length of Morse, just like that, we're going to go ahead and at that point we're going to go through each character in our Morse code sequence and we're going to pull them together as the different sequences and then we're going to translate them. So the first thing we'll have to do is we're going to have to get the character from the Morse code sequence. So here we'll do current plus equals our Morse of index. So that's going to take these dots that we have, it's going to take the first dot and it's going to put it on there. Then what we're going to do is we're going to say if the next character is a space, because remember we're separating everything by spaces, then the sequence is finished and we can translate. So we can say if Morse, that's why we use index here, if index plus 1, so the next spot is equal to a space, then we can then search for the sequence in our Morse code table. Okay, so just like we did before, we're going to do for item in Morse code. And right here, we're going to say, oops, sorry about that. Right here, we're going to say once the actual sequence is found, we're going to concatenate the letter to the output string, so the one we found. So we're going to use that table basically backwards. So what we're going to do is we're going to say right here is we're going to say if current, the one that we have, the sequence we have, is equal to item, and it's not 0 this time, it's 1. Because we're looking at, again, notice this, we're dereferencing the list. So now we're giving each individual list, and we're trying to check against this second part now. So if it's equal to item of 1, then we want to do output plus equals item of 0. Now in this case, before we actually added a space, but because we're doing text and our text currently also has the option of spaces, we do not want to put a space there. Okay, so we'll just add the letters into the actual string, and they'll make sense here in a second. And then before we leave, so after we've actually searched it, we want to clear the current string for the next Morse code sequence. So remember, this current is just a temporary variable. If we do not clear it, it's going to cause problems because our Morse code won't match up. So we'll do current equals an empty string. All right, and then we want to skip, now here's the thing, we want to skip the next character as, or should I say skip the next index, as the character is a space that separates sequences. Okay, so we're going to do index plus equals 1. And then regardless of whether we're in that if statement or not, we're also going to increment the index here as well. All right, so let's go through this. So what this is actually doing is we're coming down here. So we have our Morse. So let's imagine that we have this input text here. So we have our input, we have our output is nothing, is empty, our current is nothing. Then our index is 0, so we start at 0. So we're starting at the very beginning of this actual sequence here, the string. And while it's less than the full length of the string, we're going to take the first letter, or the first character. So in this case, it'll just be this dot right here. So just that dot right there, we have that. Is the next one after it, is this second dot right here, is that equal to a space? It's not. So we increment the next index. We get the next dot, so now we have 2 dots like that. We look at the next one in the list, is it that one? And we say, is that a space? It's not. So now we go again, we have 3 dots. Then we say, is the next one in the list a space? Or the next one in the string a space? It's not, it's a dot. So we get the 4th dot. So now we have 4 dots. Is the next one in the list, or in the string, the sequence, string, list, whatever you want to call it, is the next one a space? Yes, it is. So because it is, we're going to take these 4 dots, that's our current right here, that's what we're looking at, and we're going to look through our Morse code and find out which spot has items of 1 as 4 dots. If we come up here, you go to H, it's got 4 dots, that's the spot. So because of that, we're going to add the H to our output. After that, because we found the spot, we're going to reset this to empty. So now our current is not 4 dots, it's empty. And we're going to increment 1. So remember, we're currently at this point on this 1 dot right here. That's our index. Right here, this blue dot right here, that's our index. By incrementing 1, we skip over this space, just like that. So now we're at this dot next. So we're here, we increment. So we're here. And the next loop, we're going to be on this dot right here. So with that being said, we go to the next one. Our current's empty. We come up here, we add a single dot to our current. Then we say, is the next spot a space? It is, right there. So our current index, or current actual sequence, is just a dot, which is E. So as you can see, we're slowly building H, E, L, L, O, and then we'll be hello world. So if we come down here, we can go ahead and do the same process here. And we can say, convert the Morse code back to text. So we'll say text equals Morse to text, and we'll have our Morse here, and we can print our text here. So if I run this now, you'll see if I say hello world, we now have, you see, I never actually returned it. So one of the problems is we don't actually return anything, so it's none. So if I come down here, return output, and then run it one more time, we say hello world. And now you see we have hello world in all caps. Why is it all in all caps? Is because our Morse code is stored in all capital letters, just like that. All right. So that shows how Morse code actually works for you. Understand it, understand how, back over here, understand how we're iterating through the string. This is a little bit more of a complicated example, but again, it's to get you prepared. You need it. Not only is this helping you with strings, it's also helping you with lists, because you need to understand lists to do this kind of process. Okay? So we're going to go ahead and move on. If you need some time, pause the video, go back, rewind, do what you need to do to understand this example as well. Okay? All right, so moving on, like I said before, strings are just a type of sequence. And just like with lists, just like with tuples, you can take slices of them. Now this is very useful. So remember what we talked about before. If I wanted to change the word, if we come back over here to our Scratchpad, if I had, let's say, name equals tiger, like that, and I wanted to change that to liger. Well, instead of having to change everything, what I could do is I could say new name equals name, or I can say L, so we wanted to have an L, and we can concatenate that with part of this name. Now notice here, we just don't want that first spot. So just like we did with lists where we only want part of the list, we can do name, bracket notation, and we can say starting at 1, going to the end. Okay, remember, when you're using the colons, the first spot you give it before the first colon is your starting one. If you don't specify, it starts at 0. The next one between the 2 colons, or after the first colon, will be your end, which if not specified will be the end index. And if you want every other step, or every third, every fourth, you can specify a step size as well. Okay? Remember, you do not need the second colon if you do not have a step size. The only colon that is required when doing slicing is this first colon. If you're doing a step size, you need the second one, but if you leave the step size off, you do not need the second colon. Okay? So for instance, if I come over here, I'm saying I want to start at 1. Remember, the indexing starts at 0. So we're skipping the T and we're going to give it IGER. Okay, that's what we're looking at. So if I print the new name now, just like that, and I run this, you'll see it says Liger now, because it took the L that we had, sliced everything but the first character off, just like that, and concatenated that everything else, so IGER, this part, concatenated it to the end of L. So remember, this is not changing this string. This string is still immutable. What it's doing is it's getting a copy of these last 4 items, and it's taking this string that we have, and it's concatenating them in a brand new string. So we're not changing the current strings, because remember, strings are immutable, but we are creating a new string. Okay? So string slicing is very important because when we're working with strings, and you'll see it later on in examples, that's working with these strings can become cumbersome if you do not have that ability. All right, so here's another example here. For instance, if we wanted to slice right here, you can see we have Dolores Patton. And what we can do is we have our space location, and this right here is going to go through, and we're going to look, and we're going to find the space in the string. We're going to get that index, and then we're going to slice the string so we can say their first name and their last name. Now notice here we have this +1 right here. So remember, we're finding the location of the space. This goes up to, but does not include the space when you use the end. Remember, end right here does not include the spot you give it. It's like the range function. However, the start does include that spot. So we don't want to start with the space, otherwise we'd have an extra space before the last name. So by doing +1, we're actually starting on the P right here instead. Okay? So just like with lists, we can also do testing and searching in strings as well. So where we said before, if item in list, we can now do is a substring in another substring. So this is very useful if you're trying to search for different pieces of text. If you've ever used the find command or the find and replace command on the internet or on any web browser or any IDE, this is the idea. You're basically finding every instance of a string in an actual document. So for instance, if I come over here and I have name right here, if I control F, I can do name, and that's saying is name in this document. Same way. So you see names here, 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 and here. So the same way, if I come here and I say if, and we'll give it a sentence here, we'll say, hello there, my friend. Then I can say if, we'll get rid of this because that'll be a little bit crazy there. If hello in name, get rid of that too, then print yes. Okay, so if I run that, it'll print yes because this string is a substring in this. Now again, just like with lists and just like with everything else when we compare, it has to be, it's case sensitive. So if I run this, it will not run because the lowercase hello is not in that list. Okay? All right, so remember, that's going to return true or false. So when you use the in operator, you can use it with an if statement like that. You can also save it as a Boolean value, which is true or false. So here's another example. If we say 7 years ago, we say if 7 is in text, and we can say, hey, it was found or it wasn't found. This will result in, yes, it will result in it is found because 7, exactly like that, those exact letters, that exact character sequence is found right here in the larger character sequence. All right, so let's just see if you guys understand this. So if I gave you this code and I said, what will the following code display? So I have my string, which is A, B, C, D, E, F, G, and I print my string, which is 2:5. Remember, we're starting at 2, ending but not including 5. So we have 0, 1, 2, that's our C, so we start there. 3, that's D, 4, that's E. 5, remember we don't include 5, so we have C, D, E right here. Same thing here. Remember, we can use negative indexing as well. So if I have the same thing but do -3, we're going, this is 0 at A, -1, -2, -3. So our starting index is E. The colon's here, there's nothing after, so we go to the end of the string. So that's E, F, G. All right, so if I come down here and I say my string, I have A, B, C, D, E, F, G, I say print def in my string. Okay, is def in my string? Doesn't look like it, but if you look in there, you have DEF. So remember, this returns true or false, so it's going to print the Boolean value true. It doesn't print the string true. This is a Boolean value true. Okay. Then right here, I say, is C in my string? Well, it is, but I gave it a capital C. So with that being said, we have a lowercase c is not the same as a capital C, so it prints a Boolean value false. Okay. All right, so let's go ahead and try this one. So we're going to write a program that gets a person's first, middle, and last names and displays their middle and last initials. So for example, if the user enters John William Smith, the program should display J.W.S. So just the initials. We're going to iterate through the string. Right here, we're going to iterate through the string that we're given, like John William Smith. And we're going to find each of the spaces. And we're going to use string slicing to get each of the name parts, and then use string indexing to get the first letter of each of the names. So what we're going to do is we're going to go back to our actual pad here. We have it right here. And the first thing, just like we did before, especially when working with strings, we're going to usually get users' full names. We're going to user input, full name with spaces separating, yep, their first, middle, and last names. Okay, so we'll say response equals input, enter your full name, just like that. All right, so then with that, we need to, like it said, we need to find the index locations where there are spaces. All right, now sometimes people have more than one last name or they have more than one middle name. So what we want to do is we do namespaces equals a bracket like that. We'll do index equals 0. And we'll say for index in range of length of response, like that. We're going to say if response of index equals a space, like that. Then we'll do namespaces dot append that index. So it gives us the actual index location. All right, so with that being said, we can then split the name on spaces. And what we can do here is we'll do first name. So we'll do first equals response. Remember, we're using this slicing notation now, so we'll do colons. We won't start at the beginning. We're going to go to namespaces and the first space it found, which is 0. Okay? So that's going to go through, and if we have John William Smith, it's going to give us the first space. That's going to give us this first space right here. We want to start at the beginning and go to not including that space. Okay? We do middle. We'll do response again. And this time we want to start on the spot after this space. So we're going to do namespaces of 0 plus 1. Now, remember, this right here is an int, so we don't have to cast nothing right there. And we're going to add 1 because we want to skip past this space right here. Okay, there's a space between the N and the W here. All right, so with that being said, we're going to put a colon down right there. So now we're going to go to our end, and we want to end on namespaces of the second namespace we found, which will be the one space between M and S right here. So that, remember, that doesn't include that space, so we're okay. And we'll do last equals response as well. And this time we're going to do the same thing. We're going to do namespaces of 1 plus 1 to skip the space, and we want to go to the end. Okay? So if I print all these right now, so print first, we'll print middle, and then we'll print last, just like that. If I run this, we enter a name, so we'll put in John William Smith. You'll see we have John, William, and Smith. Now, if we took out these plus 1s on both of these, and I ran it again, we'll do John, William, Smith. Now you see they both have this extra space in the front because we're including it. But by adding this plus 1, we're taking that out and saying we do not want to start on the space, we want to start on the spot after the space. All right, so now what we can do is we can do print, we can do initials, and we can do curly braces. We'll use the print formatting notations. We'll do curly braces dot, curly braces dot, curly braces dot, and then we'll do dot format just like that. And we'll do first name, so we'll do first just like that. Yep, so we'll do first like that. We'll do comma middle, comma last, just like that. All right, so let's run that, and let's see what that gives us back. So we'll do John, William, Smith, and you'll see it gives us John William Smith, right? So we have the full names, but we don't want the full names, we want the first letter. So remember, here's the thing. Strings are sequences. So if we just want the first letter, we just got to do bracket 0, bracket 0, bracket 0, just like that. So it gives us the first letter in that sequence. So if I run this again and we go to John William Smith one last time, it'll give us J.W.S. Okay? So that's going to give us the ability to print the user's initials, just like that. All right, so again, what we're doing is we're using string searching and string slicing to go through and actually get this information from the user. So again, you see up here, we have our first, middle, and last. We're using string slicing to get those. We're using the searching methods right here to find the spaces. And then we're using string indexing right here to actually get the letters. All right, so with that being said, what I want you guys to do now is go ahead and try this on your own. So on D2L, you'll find a Python file for E source code folder. And in that file, under Chapter 8, there will be a file called text.txt. That file is going to look like this right here. Each of these lines is a different sentence right here. And what we're going to do is we're going to write a program that reads each line from the file into a list. The program should then ask the user for a search word. So for instance, if I put in the word Henry here, am, eighth, it should search for that word. And it should iterate through each line in the list and count the number of sentences the search word occurs in. And upon completion, the program should display the search word as well as the number of sentences it occurs in. You also get some bonus points there if you can add functionality to your program so that it calculates the average words per sentence and displays the average upon completion. So go ahead and pause this video, try it on your own, think about it, don't just jump right back in, think about it. And if you can, and after you've tried it on your own and you get stuck or you don't know where to go from there, or if you do finish it and you want to see if you're right, unpause the video and we'll go over it. All right, did you guys give it a shot like you were supposed to? All right, so let's go over it together. So the first thing you're going to need is you're going to need the text.txt file. We've covered this in the past, but all you would need to do is go to D2L, download underneath the course resource, the Python 4E source code folder, and inside of that you'll find a document called text.txt. All right, so once we have that, we're going to go over to, because we're on example 8.6, we're going to go over here. And what we're going to do is we're going to first read the lines into a list like we've done before. We're also going to strip the new lines, and we're going to uppercase them for later comparison. Okay? So we're going to have our lines list here. So we have lines. Now remember, there's multiple ways to open a file, and I'll show you an alternative way where we'll do with open. We'll do text.txt, open it with a read. We'll say as fp. Now what this does is it puts us in a scope here with the with command, and that's going to mean that once we actually finish reading everything here, it will close the file automatically for us, so we do not have to do it. So now what we're going to do is we're going to do lines equals. Now we can do fp.readLines like this. That will require us to actually sanitize it later. But if we do fp.read like that, that gives us a whole bunch of text back. We can then do .upper on that. So that's going to uppercase all that text. And then we can do .split lines like that, and that'll make a list for us that is sanitized. The split lines will split on all the new line characters for us automatically. All right, so if I print lines now, I run this, you'll see we have everything in capitals. There's no \n anymore, and this is an easy way to go about that. Okay? So once we have our lines, we want to get the user's search term that they want to search for and uppercase it, just like we did before, to compare against the lines. Okay? So we'll say search equals input. We'll say enter your search word, like that. We'll do .upper on that, just like that. And we'll look into these .uppers and .lowers more in a little bit here when we talk about the string methods. But for right now, just know that .upper will uppercase the string that you attach it to. All right, so next what we're going to want to do is we're going to go through each line checking for search terms, or the search term. So we'll say found equals 0, just like that. And we'll say for line in lines. We'll go through each line. We're going to then say if found in line, increase found counter. We'll say if search in line, found plus equals 1. All right, so remember, just like we talked about over here, when you're looking at it, you can say, is a string in that? So if I come over here and I say, is, look at this here, we say, is in this first string right here, this entire first string, is the word am in that list? Yes, it is there 3 times. 1, 2, 3. Remember, when you use in, it does not count, it just says true or false. So we'll just do found plus 1 there. And then after that, we'll come to the very end, and we'll print our search term and the number of times it was found. So here we'll print found blah blah times. We'll do .format, and we'll do our search term, and then we'll do the found as well. So if I run this, it'll say enter the search word, we'll do am, and it'll say it found am 10 times. So if I go back into our text document here, we count them. If I control F, am, like that, we'll do whole word, that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice here that the casing does not matter because over here we have made both of them uppercase. All right, so we did the first part there. We printed our word, we did what we needed to do, but let's go ahead and add that functionality so that we can calculate the average words per sentence as well. So what we're going to do is we're going to come up here and we're just going to count the words. We're going to do word count equals 0. But there's one thing, we haven't actually talked about how to count words yet. So what we're going to do is we're going to go ahead and talk about this, but we're going to go into it in more detail here in a second. We're going to go ahead and add number of words in a sentence. Now we could do what we did before, where we could find all the spaces and we could split things as well, but there's an easier way to do that. So what we can do is we can do word count plus equals the length of line dot split. Now dot split here, this function right here, goes off of a sequence, and this split will split this sequence wherever there is a space. Okay? So what that does is, if we look at this, it's going to give us a list of items where it's going to be I'm is the first item, Henry is the second, the is the third, eighth is the fourth, eighth specifically, eighth with this comma right here. So it's this entire thing right here. So eighth with that comma. Then you have I, am with an exclamation, Henry, the, eighth again with a comma, I again, am with a comma, and so on. Okay? So that split is splitting the actual string based on the spaces. We'll talk about that more here in a second. But by doing that, we make a sequence or a list. And then by getting the length of that, we can add the number of words in that list or in that sentence. So then if I come down here and I do print, and I say average words per sentence, I would do dot format, and I'll do word count divided by the length of the line, so the number of lines we have. If I run that now, we now have the word am again, and it'll say your average words are 7.375, which makes sense because if you look here, we have 1, 2, 3, 4, 5, so we have a few short lines. And then we have ones that have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines on that one. Okay? So 7.375 seems about to be the right number. Okay, so that's what we're doing. So we'll go over split here and more in a second, so don't worry too much about that. But for the meantime, understand that we were able to read the text in, get a search term, go through, and we use the in operator to find the number of times that it actually occurred in the input text in each of the lines. Okay, so moving on from there, as we were just talking about, we have some very useful string methods. We've used a few in the past because you really can't get around using them because they are so useful. And the way they work is you take some kind of string, whatever your string is, and you use the dots and then the method that you're using. So like dot upper, dot lower are ones that we've used before. And again, you put them at the end of your string. So over here, if I come over here and I say, hello there, my friend, and then I do name dot upper, and I print that, that will give us hello there, my friend, in all caps. If I do dot lower, it does the exact opposite. So it's all lowercase now. Okay? So there's a lot of different useful string methods. For example, we have our check methods. So we can say is alpha. So that what that's going to return is only returns true if the string contains only alphabetic letters or digits and is at least one character in length. We have is alnum, which that was is alnum. Is alpha only returns it if it's alphabetical. Is alnum returns it if it's alphabet and numbers. So there's no like dashes or dots or anything. We have is digit, which will return it only if it includes numeric digits. We have is lower, which only returns true if everything's lowered in it. We have is upper, which does the opposite. And we have is space, which returns true if the string only contains white spaces, like sort of backslash n's, backslash t's, or regular spaces. All right, so that's our testing methods. So here's an example of when we're here, we say is digit, so we say enter number. Now remember, is digit, by the way, only works with numeric digits. It does not work with dots. So you cannot really use it to test for floats. You can only use it to test for like integers. So you could say, is that digits? If it is, then you say your number squared and you can convert it to a float, an int, whatever you want to do. But again, remember, it does not work on decimals. Okay? So then we have our string modification methods. So we've already used dot upper and dot lower before. We've used dot strip before. And then we also have left strip, right strip, and the actual strip character. So what this means is with left strip, it returns a copy of the string with all the leading on the left of the string is removed. So for instance, if I come over here and I put a whole bunch of spaces here, and we'll put, yep, right there, we'll put a whole bunch of spaces here like that. If I do dot L strip, I run that. Over here, you'll see we have a huge amount of right empty space right here. If I change this to .r strip, we have all this front leading empty space. If I do dot strip like we've used before, it gets rid of both, and the entire text is just the actual starting at all the characters. There's no empty white spaces around it. Now, if you wanted to, you can do a character, and that will remove all the leading instances of a character. So for instance, if I did dot L strip, so leading strip, and I did, let's say H, if I run that, it's not going to do anything because all this empty space is here. But if I get rid of that empty space, and the first character in the list here, or in the string sequence, is an H, then it will remove the H. So if I had a whole bunch of H's here, like that, and I run that, it'll also remove all those H's as well. Okay? R strip does the same thing on the opposite side, and dot strip does the same thing on both sides. All right, so an example here is when you're getting user input, you want to get rid of the white space, you want to uppercase it, and then you can also go ahead and you can put out the name, you can compare it, you can do whatever you want with it, but this gives you full capabilities to manipulate the string. All right, then we have some search methods, just like we do on the actual internet, like we talked about before. You have .find. So an interesting combination here is you can say, if I come back here and I say, hello there, my friend, and I can say, we can say, if there in name, which it is, we can print yes. So we've done this before. If I run that, it'll print yes. Then I can do, right here where we have find, I can do name dot find, and then it asks me for the actual substring. So I can do there, like that, and I can print this just like that. If I run that, it prints 6. 0 is H, remember, 1 is E, 2 is L, 3 is L, 4 is O, 5 is a space, and that 6 is the beginning location of that substring in that list. So you can use the in operator and the find method in conjunction with one another to check to see, does it exist, and where is it at? And that's how you can do that. Now, if it doesn't find it, it returns a -1, but it's nice to know that it does exist before you even try to find it, so you're not wasting your efforts. So then you have dot starts with and dot ends with. These are very useful. So for instance, dot ends with is very useful for checking for like .coms, gmail at gmail.com, at yahoo.com. It's really useful for finding emails. Dot starts with is good for finding like titles and stuff. Like, oh, this person's name starts with .dr doc, then they're a doctor. Oh, it does start with an mr dot. Oh, that's a Mr. So on and so on. And you also have replace, which is also nice for if you're working with like large pieces of text as well. All right, so we have all those different methods, just what I was talking about right here with the actual emails. You can say does dot strip, does it end with .com? You find this @ sign. If you can't find an @ sign in it and it doesn't start end with a .com, then it's not valid. If you do find that, then it is valid. Okay, so just like we did before with lists as well, one last thing I want to go over real quick is we also have the repetition operator. So the repetition operator makes multiple copies of a string and concatenates them together. So the star symbol is a repetition operator, like we did with lists, where we can then say, if I come over here and I do times 10, and I print name, what do you think that's going to do? It says the exact same string, it replicates it over and over and over again, all in one string. So just like we did with lists, where we wanted to make a list of size 10, you can make a string of some repetitiveness on there as well. Okay? We just talked about this a second ago, but this is how this works. So when you use the dot split method, which is a very useful method, it will split it on spaces, or it will split it on a character. So for instance, if I have hello there, my friend, instead of that, let's say I have, let's actually, you know what? Let's do this. I'll do name dot split, and instead of splitting on spaces, we're going to split it on E. So every E, it's going to take out the E's and then break the string up based on those. So if I run this, you'll see it says H, there's an E, so it stops that list item, LLO space TH, then there's another E, so it splits it right there, R, then it splits it again because there's another E, then you have a space, and then my friend, and then there's an E, and then you have ND. So you can split on spaces. This is the one you're going to use most of the time, splitting on spaces. But You also have the ability to split on specific characters as well. So if I split on L's here, you see we have an empty string here because this is the spot between the two L's, so there's nothing in there. But this breaks it up completely based on those L's. Okay? So make sure you understand the split method. Make sure you understand the repetition operators as well because they're very useful. And here's another example. We can say hello world, we split it on a comma, multiply it by 50. And what that's going to do is it's going to make hello world 50 times. Or specifically, actually, here, if you notice, we say list sub 0. So it prints a whole bunch of H's because the first letter is H. Okay? All right, so let's see if you guys understand this. So what will the following code display? So if I say ch equals a, I print ch, comma ch dot upper, it's going to print a followed by another a, with, in this case, a capital A. If I have var equals p% and I lower it, the lower will only work on the letters, so the capital P does not get lower, so it's just a lowercase p. If I then say I have A, B, C, D, E, F, G, capital A, capital B, capital C, and I say dot replace B, notice here, it's going to replace B with an empty string or a space. So it takes B out and leaves a space there, but it does not touch the capital B because remember, capitals and lowercase are two different Unicode characters, which means they're two different symbols in the computer's memory. So if I ask here, what will the following code display if I have \n, \m, \t, space, \l, is space? Remember, \m is a space, \n is considered a space, \t is considered white space. All three of these are considered white space. A space is considered white space. This \l is not. Okay? All right, we go on a little bit further. If I say hello, and I strip L strip with the commas here, we have 3 commas on both sides. It'll take all 3 of the commas out on the one side, so we have hello followed by 3 commas. If I have var times 10 dot upper, that's going to give me 10 uppercase X's. If I say hello world, how are you? And I split on the spaces, it's going to give me hello world, how are you? Now notice here, you have the punctuation still, so you have the comma after world, you have the question mark after you. If I split on O's now, it's going to say hell, W, RLD space, or RLD comma space H, WRY comma U, question mark. So remember, you have full control. So at this point in this, you have full control over these strings. And you can do whatever you need to do to manipulate them, take information out, put information in. And this is very useful information for actually working with user data. All right, so let's try this. It's a very simple one. And what we're going to do is we're going to write a program that will read a string. That'll read a string from the user containing a date in the format of month, day, year, split with the slashes in the middle. And it should print the date in the format of March, the full month, the day, comma, the year. Okay? So we'll go over H-3 for that. And again, I already have this list here, so go ahead and write that into your own code. Pause the video if you need to. And what we're going to do is we're going to start by setting the initial date string to an empty string. Just like that. We'll say date equals empty. That's what we're going to use later to store the actual result. Then we're going to get the user input for the date. So we're going to say user date input validation. And we're going to say while true. We're going to say date equals input. And we're going to say enter an input date of this form. I'll put that there so they can see that. Then we're going to then ensure the date is in the correct format. We'll say if date of 2. So remember, we want, this is our date right here. We have 0, which is M, 1, which is M, and 2 is this /. If dates of 2 is not equal or is not equal to a /, and date of 5, which is this other slash right here, is not equal to a /. Showing there. Then we want to print invalid date format, just like that. Else, which means we have a valid date now, we can break. Now we can go further with this input validation if we wanted to, but for right now, that's a decent spot. So we can then split the string based on forward slashes, like that. A little too many L's here. We're going to do date parts, date underscore parts equals date dot split. We're going to split this on forward slashes. Okay. With that being said, if I print date parts now, remember that returns a list. So if I run that, I put in, let's say, 01, 12, 2022. It'll give us 01, 12, 2022. So we're almost done, but we don't want this 01. So what we want to do is we want to print full date. We want the month, space, the day, comma, the year, period. We'll do dot format. And we'll want the month. So we want to go with our months list that we have up here. We'll do months, bracket, and then we want our actual date part. So we have 0, 1, right? However, remember, lists do not start at 1, they start at 0. So we're going to get our int, we're going to cast that date part that we have, the first date part we have, which is the first one, which is at 0, 1, to a 0, like that. I'll make this a little bit easier to see here, like that. And we're going to take our date part that we have, and we're going to subtract 1 from it, because again, this is going from 1 to 12. We want to go from 0 to 11 to get it in this month's list. So that'll give us the actual first part. Then what we want is we want our date parts of 1, which is going to give us that 12. And we want the date parts of 2, which will give us the 2022. So if I run that again, we can go ahead and get rid of this part for now. Run that again. I do 01, 22, 2022. It gives us the January 22nd, 2022. So again, this right here is going to print each date part, and it's going to subtract 1 from the month index since lists start at 0. Okay? So that's all there is to it for this one. All we're doing is, again, we're just getting the actual date right here. We're going to go ahead and get the user input and make sure it's valid. Is there more validation we could do for this? Yes. Should you do more for your actual projects and stuff you turn in? Yes. You should go as far as possible to make sure that there's no issues with that. And then you should split the strings based on the forward slashes, just like that. And then we're going to print out each date part right here, and it's going to turn out just like this down here. Okay? All right, so that's this first example. So what I want you guys to do now is I want you guys to write a program that accepts an input as input a sentence in which all of the words run together, but the first character of each word is uppercase. So think camel case. For instance, right here, you have stop and smell the roses, but every first letter is capitalized. And what you're going to do is you're going to convert the sentence to a string, in which the words are separated by spaces and only the first word starts with an uppercase letter. So again, you have stop and smell the roses, camel cased, and it should convert it to stop and smell the roses, and everything is correctly punctuated. So go ahead and try that on your own. Pause the video, take some time, because the best way to learn is to pause it and do it yourself. Pause it, get as far as you can. If you complete it, great, come back and see if you did it right. If you don't complete it, come back and see what you did wrong. But once you're ready, go ahead and unpause the video and we'll go over it. All right, did you get a chance to try it on your own? So let's go over this. So we're going to go over here to 8-12. And what we're going to do is, again, the first thing we want to do is we want to get the user run together sentence. Sentence. There you go. This, and we're going to give you an example here. So this should be in this format. So we'll just put that there so they can understand what we mean. We'll say sentence equals, run-on sentence is more like I can't spell, but that's okay. Input, we'll say enter a camel case sentence to decipher. Okay. that. All right, once they've done that, what we want to do is we want to set the output and current word strings. So just like we did before, where we had a current word, when we're working on individual words and splitting them up, we're going to use this current word string. We're going to do output equals an empty string, so that's going to be our final output, and current equals an empty string as well, but that's going to be a temporary one. We're then going to iterate through the sentence and find the capital letters. That's our delineator. That's how we know which one we're on when we're to another word. So we're going to do for index in range of len of sentence. We're then going to say if the letter is not the first letter and it is a capital letter. So we'll say, specifically, we're going to say if sentence of index dot is upper, so we're going to use this to check is it upper, and current is not equal to an empty string, just like that. Then we're going to store the actual current word to output followed by a space. So we'll get to that in a second, but let's go ahead and do the else case real quick. So if it's not upper, then all we want to do is we want to do current plus equals sentence of index. So if it's not uppercase, we just want to add it to the current word that we're working on. And if it's the first letter, it's going to be capitalized, but this will be empty, so that's okay. And if it's not upper, then we're going to do if letter is not a capital letter, add it to the current word, just like that. All right, so once we actually find another capital letter, what we want to do is we want to do output plus equals the current word. So we found another capital letter. We have our current one. So before we add the capital letter to the current word we're looking at, we want to store the last current word we were looking at. So that'll store that, and we're going to add an actual space there as well, just like we did before. Then we want to clear out the current word and set lowercase versions of letters of the capital letter to the current word. And I'll go over this here in a second. What we're going to do is we're going to do current equals sentence of index dot lower. So remember, every subsequent capital letter, if we go back over here, is supposed to be lowercase. So the capital and here is going to be lowercase. Smell is going to be all correct punctuation. Okay. So with that being said, if we come in here, this is what we have, and we can go ahead and print the corrected sentence at the end. We'll do print corrected sentence. We'll do a little bit of formatting here to make it look nice. Do dot format. And we'll say output. Okay. All right, so if I run this now, and let's go ahead and run that, and let's say stop and smell the roses. Okay, so something was wrong there. What happened? So let's first look at this first. What happened and what did we miss? So let's step through the process and see what went wrong. So the first letter in this list, so we go through our sentence, we're looking at each letter in this word right here. So the first one is this capital S. We say, is that upper? It is. But current is currently empty. Okay? It's going to bother me if I don't fix that. All right, so it's currently empty. So because it's currently empty, we're just going to add that capital S to our current word that we have. And then we go to the next one. So now we have our lowercase t, that's not upper, so we just add it. O, it's not upper, so we just add it to the current. We have P, it's not upper, so we currently add it. Then we get to capital A. It's upper, and we already have text in current. So what we're going to do is we're going to say output is stop. So we're going to put this stop, S-T-O-P, that's going to go into our output. The space here is going to go into our output, and then the current is going to become equal to just the letter A, but it's going to be a lowercase version of A, which is this A you see right here. We do the same thing with A, we do the same thing with N here. So right here, Is N upper? No. Is D upper? No. Is capital S upper? It is, and there's still stuff in current. So with that being said, we're going to store A and D out to the output, followed by a space, and then the current becomes a small s like that. Now, notice what I've been saying this entire time. There's something in current, there's something in current, there's something in current. The last word, when we get to roses here, the one word that's missing, look, the only word that's missing is the last word. Because we get to the capital R, we put the R in there, we have O-S-E-S. We get to the very end, and we put that last S in there, but we never put that current right here. Once for this last word right here, roses, we never go through and actually add it to the output. So what we need to do is we need to have a last step here. We need to add the last word in the sentence to the output. So what we'll do output plus equals current, because that data was never written. So if I run that one more time, we'll do stop and smell the roses. And now it's perfectly fine, just like that, okay? So just keep that in mind. So again, in this case, what we're doing here is we're going through, we're using our string search methods, our string indexing. We're going through, we're checking, is it an uppercase? And is that other one empty? We're going to go ahead and add it. We're going to go ahead and cast this to a lower string. And then after that, we're going to go ahead and add to the actual string as well. Okay. If there's any questions, go back, look at the comments I've put in this code, rewatch the video, make sure you understand this as well. Don't miss that in there. All right. So with that being said, what I want you guys to do now, I want you guys to try one more. All right, just one more. I want you guys to write a program that accepts a sentence as input and converts each word to Pig Latin. So in one version of Pig Latin, to convert a word to Pig Latin, you remove the first letter. This is what I want you guys to use. Remove the first letter, place it at the end of the word, and then I want you to append the string AY to said word. So if you have the word, the English here that says I slept most of the night, you would have I as the first word. You can't move I to the end of the word because there's only one letter. So you just add AY to the end, so it's IA. Then you have the word slept. Notice how you take the S, put it at the end, so you have leps, you put A at the end, AY at the end. Then you have most, you move the M to the end of the word most and put an AY at the end. You have of, so since there's only two letters, you flip the two letters, put AY at the end. You have the word the, you move the letter T to the end of the word the, and put an AY at the end. And then you have night, you move the letter N to the end of the word night, and put an AY at the end. All right, so what I want you guys to do is I want you to write a program that will accept the sentence as regular English and convert it to Pig Latin. And then as a bonus, I want you to also write a program that will convert it back from Pig Latin to standard English as well. So go ahead, try this on your own. It's a little bit more difficult, similar to the Morse code one in a lot of different ways. But try this one on your own. It's good practice. See if you can do it yourself. Once you're ready, go ahead and unpause the video and we'll go over it. All right, did you get a chance to try it on your own? So let's go ahead and look at this together. So what we're going to do is we're going to come over here, and just like with everything else, we're going to go ahead and make a couple functions too, just like with the Morse code. So what we're going to do is we're going to do def, we're going to do text to Pig Latin. We'll have text here just like that. And then we're going to have another one called def Pig Latin to text. We have our Latin coming in just like that. We'll call this, make it simple, we'll call it Latin text. Okay, so let's start with text to Pig Latin. So the first thing we want to do is we want to split the sentence text into individual words. Okay, so we split them into individual words. So we can do words equals text dot split, just like we did before in the last section there. And what we're going to do is we're going to iterate through the sentence words and convert them. Okay. So we'll do Latin. So we have our Latin words here. It's a list. We're going to do for index in range of length of words. And we're going to say get the word. So we'll get word. So we'll do word equals words of index. We'll then store the first letter of word string. So we're going to store the first letter because remember we want to put it at the end. So what we're going to do is we're going to say first equals word of 0. Then we're going to remove the first letter of the word string. So what we're going to do, remember, we can't really remove it, but we can make a brand new string that doesn't have that. So we can do word equals word. We use string slicing, so we want everything but the first one, just like that. And then we're going to add, it's up here a little bit, yep. Add the first letter and the letters AY to the end of the word string. We're going to do word equals word plus first plus AY. Then we're going to go and just capitalize the new word, just make it simple, make it also very uniform. So we'll do word equals word dot upper. And then we can go ahead and append the new word to Latin list. So we'll do Latin dot append word. All right. So it's a multi-step process, but what we've done is we've basically just moved the letters around, added AY to the end, and we're good. So then what we're going to do is we're going to return the Pig Latin sentence. So remember, right now we currently just have a list of words. So what we need to do is we need to do Latin sentence. This is another function that we're going to talk about here. I can get this right. Sentence. There we go. Not an English major. It's all right. We're going to put spaces like that, and we're going to do dot join. We're going to do Latin. So what the dot join function does is it takes every list item and joins them with a space, just like that. Okay? So when I do that, it's going to put the actual Pig Latin in the correct order for us with spaces in between each Pig Latin word. So we'll go ahead and return. We're going to return the Latin sentence like that. Now, because we can't just leave an empty function, we're just going to put pass here just to keep it there. It's like just a placeholder. And if we come down to main, we can do sentence equals input, enter a sentence. Just like that. And then we have that. And what we're going to do now is we're going to do Latin equals text to Pig Latin with our sentence. And then we're going to print Latin. All right, so let's go ahead and try this. Let's go ahead and run this. And if we say hello there, it's going to say LOA hirate. So there's the H from hello. The rest of the word hello is right there with AY at the end. And there's the T for there with the rest of the word there right here before it, followed by AY. All right, so now we have our Pig Latin. Now how can we go backwards? So to go backwards, it's the same process. So we're going to say split the Latin text. So we'll split the sentence text into individual words again. So we'll say Latin equals Latin text dot split, just like that. Then we're going to iterate, just like we did before, through the sentence and convert the words back to English. Okay, so we'll say words equals an empty list. And we'll say for index in range of length of Latin text or Latin. Just like that. Then what we're going to do is we'll say get the Latin word. So we'll say Latin word equals Latin of index. Then what we're going to do is we're going to store the first letter, but not for the first letter, but we're going to store the first letter from the end of Latin word string. So remember, the first letter is at the end, but it's not actually at the end. It's 3 from the end. So we're going to do first equals Latin word, bracket, -3. That's going to be, if we look right here, 0 is H, -1, -2, -3. So we want that -3. There's always going to be an AY at the end, so we're okay with that. So after we do that, we're going to go ahead and remove the first letter and AY from the end of the Latin word string. So we'll say Latin word equals Latin word bracket, and we'll do colon -3, or colon -3, because we want to stop at -3, which will leave those 3 off. And then we want to add the first letter back to the beginning of the word string. So then we'll say word equals first plus Latin word. Then at that point, we can capitalize everything, which already should be, but just to be safe, we can do it again. Capitalize, capitalize. There we go. New word. All right, we'll do word equals word dot upper, just like that. And then we can append that to our output. So we'll do append to output list. Okay, just like that. We'll do word. So we'll do words.append word, just like that. All right, so just like that, we have our words, and we can go ahead and return the true sentence. And that's going to be, I promise my N key is breaking, so don't worry about that. So sentence equals, we'll use join again, with a space there, dot join. We'll do of words, and then we'll return sentence. I promise you that N key is breaking, it's not me. All right, so what we'll do is we'll do true equals Pig Latin to text. We'll do the Latin in, and then we'll print true. Okay, so if I run that now, if I say hello there, we have Elohe here, te, and then we have hello there. Now, to better understand what join's doing, if I take out this space right here, what do you think is going to happen? If I run that again, I say hello there, you see there is no space now between these. Okay? That's because this space is what they use to connect the different list items in a string. Okay? All right, so what we've done there is we've been able to use this process right here to convert the text to Pig Latin. We reversed the process here to convert from Pig Latin back to text. And then we have our main here, which just calls those two functions. So in all, we've seen that we can actually convert text. We can use the string splitting. And in this, if you notice, we needed to use everything. So we've used the string indexing, the searching, the iterating, the actual indexing right there. We've used split. We've used the string slicing right there. We've used uppers. We've used lowers. We've used joins. We use concatenation. When working with strings, you're going to need all of these. We've used split up here as well. So you're going to need all of these when working with strings. So it's important that you understand all of the different pieces. So again, in this chapter, we've covered different methods for iterating over strings, repetition and concatenation operators, strings as immutable objects, slicing strings and testing strings, string methods, and splitting strings. So if you're confused on anything, please don't hesitate to ask me. Also, if you're confused, you can go back, rewatch the video, redo the examples, read the book. But again, make sure you understand how strings works, because in the actual world, you will need this type of information, because when you're working with user data, any kind of spreadsheets, any kind of information like that, this will make your job 1,000 times easier. All right, thank you for joining me on Chapter 8 here, and I will see you next time when we go into Chapter 9.